Hey, hello everybody. I recognize a couple of faces here and appreciate your time. So as Jamie was saying, I worked at IBM 33 years. I was chief architect for all of Zed software across the whole corporation. A lot of fun. Owned M&A for a while, decided to buy a console company, sold the print division to Ricoh, Princeton Softtech, Platform Solutions, Cognos, and then the ZPDT or whatever it is, ZD&T now, I kind of created that for customers. It was only available to vendors. And if you really want to do DevOps in this platform, either that or ZVM is the way to go to save your money. So I had a lot of fun. And then I retired 6 years ago, and I just kind of like this stuff. So I came back to work a year ago for Rocket. And now Thomas is my European partner here. I've got rest of the world, but we focus on pre and post sales for security products, for IMS tools, Omegamon, what else? Storage products. So we keep kind of busy doing this stuff. So this is an old presentation. I've done it in the U.S. a couple of times. I'll do an enterprise security myths later on. You'll see some common slides, but a little bit different. And given my view of the world, I try and take a very holistic view of all the parts, including the desktop, going all the way down there, though this doesn't have a lot of desktop component to it. There's products named in here, but there's alternative products as well. The important thing is to understand the concepts and what are you really trying to protect. If you look at it, GDPR here in Europe, or I don't know, does that apply to you guys after Brexit? I don't know, but I would assume it does because you're operating internationally. But, the fines can be horrendous, as Mark talked about in his opening, and there's an awful lot of products out there. And the biggest problem I see is that we have silos. It's like you got an organizational silo on this, that, and the other thing. And where breaches occur, it happens in between areas. More background. So I kind of looked out for the security architecture of the mainframe. Not only is it well, I'll get to that in a minute. So, and what's at stake is just how much data is out there on a mainframe in particular. And again, lots of myths how much data is out there. But regardless, there's so much. It's very profitable to get access to this data. Back in the days when I started IBM, it was a SNA environment, SNA network, all sitting with the mainframe using physical security in a glass house. Mark Anzani's here. He'll be talking later on. But I remember when we had an ESP program, they were so worried about anybody seeing the latest and greatest hardware that they built a room around the mainframe. And we had already figured out, like I worked for Pinkerton for a couple of years as a security guard. They taught me to be a professional burglar. And so if you lock your keys out in your car out here, I'll get you in, no problem. And I've done that, unfortunately, a few times. But the raised floor, we were able, because our raised floor is 1.5 foot clearance, so we just kind of snuck underneath it, and we did that regularly. You got to be careful pulling the raised floor tile because there's a lot of air into there and a lot of crap goes in your face. But once you do that, yeah, you got kind of access to anything. So they put chicken wire on the raised floor, and then because they just assumed it was us, they put chicken wire over the top flush with the lights, and then the lights blew out. And they didn't have any way to replace the lights. So sometimes security isn't that great. But the point is, the mainframe here, where it was once isolated and separate from everything else, is now accessible via the internet. And TCP/IP, this awesome thing for communications, is also a pipe for anybody to come in and get access to the platform. And again, I'm focused on the database today, not on the whole platform. Later presentation or tomorrow's presentation, give a little bit broader view than that. We talk about data, where the personal information is and such. By the way, I'm stuck here because of the videotaping, so I can't really meander over to the wall. so much data, so many people have data sitting on a mainframe, and as well as on other platforms, but it's really critical to protect that privileged data, whether it's in the cloud, whether it's operational information or private, personally identifiable information. We get the reputation that we're the most secure platform in the world, and then you ask the question, what else do I need? Well, we're the most securable platform in the world. What I've found, going back to this picture, is that security is about people, process, and technology. And being a securable platform, we have some of the greatest technology in the world. Unfortunately, I've met a lot of morons. And, the password is password. The user ID is password. They don't put any security patches on a system. And that isn't even the way they hacked into the system. And that system was hacked via the network. So it's pretty bad, it's pretty bad what I've seen. And so the reality is it's not a secure platform out of the box. There's a lot of things that need to be done to make it more secure. Again, a lot of point offerings from a lot of vendors, but I'll try and focus on some key areas. Again, from forensic work. So forensic work, TJ Maxx, when they got hacked, it was 95 million credit cards. They were the first significant hack. I don't know, it was back early 2000s, maybe late 1990s. I knew they were a mainframe customer, and I was focused on this thing, locked on. I'll talk about it in detail tomorrow, but the bottom line is their local area network was hacked in a store via some guy looking at a Pringles can, stealing their signals. And the mainframe guys were dancing a jig. It wasn't us. Well, basically, I was able to prove that the mainframe was as insecure as their desktop systems. And they have no idea if they were hacked. And I'll give you some examples of some other forensic work that was done. So who are you worried about? External threats, internal threats, and then compliance to whatever regulations, GDPR, PCI, DSS, whatever there are. But to be honest with you, the internal threats are probably just as big as the external threats. In fact, I think 62% of the breaches of mainframes. Oh yeah, there's a myth. The mainframe's never been hacked. Okay, no, it's just been compromised then. All right, so the data's been stolen. I don't care how they got it. They got it because they stole a password typically. And where did they steal the password? Not off a mainframe, off a desktop. Okay, so that's why I kind of made it a crusade of mine when I was at IBM. If the desktop is insecure, the mainframe's insecure. So if I can secure the desktop, well, then that'll help prevent some of this stuff. Again, not part of this pitch. See the next pitch. But because of the reputation of the mainframe, a lot of people check the box mentality. We don't need to do anything. Well, they couldn't be further from the truth. Okay, and the fact is, when you get into security, again, it's a later chart. If you detect a problem, you're going to spend God knows how much money, the black hole, as I like to call it, trying to solve the problems and fix the platform. But because also, we keep, when I first started working at IBM, there was basically the base operating system, TIX, IMS, and as I worked at IBM, DB2, vSAM, and you add in WebSphere and Java and Unix system services and now cloud containers and blah, 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 blah. It keeps getting more and more complex. And then forget about things like, ZOS or Zoe, that kind of stuff being added in now. So, are all these parts, are they all secure? And lots of stuff to focus on and still manage compliance and visibility of problems. What do you have? I mean, we actually invested for a while. We had some firewall technologies on Zed. We were thinking about doing LPARs as firewall LPARs. Would have been the most expensive firewall in the world, similar to when we had Windows. And yes, we never announced it, but we had Windows running on a 3090 back in 1994, but it couldn't use ZVM, so it was a 10-way single version of Windows. So yeah, it was pretty expensive. Would have been expensive if it ever went to market. But with the firewall technology, name and address translation, that's all built into things like the TCP/IP stack, the network stack. But what's the antivirus capability of a mainframe? What's the signature of a virus on a mainframe? I think there's a couple of vendors that have some thoughts around that, but really focused on Linux, Java type things that are bytecode things. But there's 60% of all attacks that are known, and again, a lot of attacks don't get announced because of brand reputation, fear of cratering a market. It's somebody that you thought you might have known that was working right next to you. In fact, who are they? They're the bad people, bad actors, malicious employees, or a third party that has access to this stuff. Employees with privileged access. So that's going to be the next slide. But let's go back to Bradley Manning's, Edward Snowden's, and U.S. terms. Okay, I had a top secret clearance for the U.S. government for over 15 years, and after Snowden, after Manning, I showed them all kinds of ways that they could have prevented that kind of stuff happening. Yeah, good luck to them. A lot of this stuff still doesn't gets implemented because it's general purpose. These are general purpose thoughts. They're not unique to the mainframe. You've got to have the same kind of thoughts regardless of where you're running. When we introduced MFA, multi-factor authentication, we talked in particular about privileged users. And what's your definition of a privileged user? In most cases, it's somebody with some type of system authority, APF authority, RACF authority, database administration authority. That's the far right of this chart, okay? The reality is, what do mainframers, and I'm talking about not consumers, but what do mainframers within a bank, a stock broker, and stuff, what do they look at? Money, okay? They look at money. And if you can get access to them, you can have access to money, all right? So you'd think that would be worth protecting, wouldn't you? You have personnel records. So like I said, I had top secret clearance. The U.S. government uses the Office of Personnel Management. That's the HR department for the U.S. government. They got hacked. Everybody with a top secret clearance information got hacked. Now what's in there? Every one of my relatives, all my social security numbers, and every single credit card and bank account I have. Okay, that's what was stolen. Oh, and who did they steal it from? Not from OPM. No, a business partner. They gave them the data to go do security clearances on people. So OPM could have been awesome, but it didn't matter because once they gave the data to somebody else, they abdicated their authority in terms of how was that data protected and ensuring that a partner protected the data. Okay, you look at intellectual property, patents, not patents issued, patents pending. Okay, how much of that information? What's that worth to a competitor to grab that information? So basically anybody on a mainframe is accessing critical information. Anybody inside a business. I mean, consumers, the risk, they're looking at important information too, but they're looking at their data, not everybody's data. Okay, so anybody, in a claims administration role, in any type, even a secretarial role, they have access to a lot of stuff, clerks and things, admins, but anybody can see this. I'll give you a travel agent. So I went to, not a travel agent, insurance agent. I went to a local agent, and again, you get security on the brain. It's not even my job, but you get used to it. And there on their little cork board is Travelers Insurance, user ID, password, URL. Aetna Insurance, user ID, password, URL. And it went on and on and on. I'm from Hartford, by the way. I have relatives at ING, Voya, Hartford Insurance Group, Cigna, Travelers. So that's our heritage. But they had every one of them. So the first time I'm just like, oh my God. The second time I took a picture of it. And I said, hey, do you mind if I just talk to your boss for a second? I just said, you know what, it's okay to write this down, but put it in the desk. And we used to do security sweeps at IBM, and you'd be surprised how many have them right here, all written down underneath the keyboard of their desktop systems. It's or on a yellow sticky note somewhere. It's written down someplace. And once you find one, you typically find many, many others. So the bottom line is everybody on the mainframe needs to be protected, not just everybody's a privileged user, which correspondingly goes back to the evolution of transactions. It started out as, you went to a bank teller and they initiated the transaction on your behalf. Ultimately, it goes into an agent, or travel agent. You went to the airline, then an airline agent. Then the consumer could start doing stuff, and then you have devices doing things in your mobile devices, stuff. The evolution of user ID and passwords, to card swipes, and then chip and PIN. Although US didn't really get it, they only did chip, no PIN, duh, so that still boggles my mind. You get a PIN, but they don't use it. And then two-factor, now multi-factor authentication and biometrics. Personally, biometrics, because I can steal anything. I can steal your credit card and just, especially in the US, because I don't need your PIN, and accomplish all kinds of stuff. So what I find, though, is in a lot of businesses, how many of you use multi-factor authentication on your desktops at work? Right? How many of those with your hands up, how many use it on any mainframe access? Yeah, a couple. And the bottom line is, let's just think about this workflow. I do multi-factor authentication to my desktop. Why? Because it's insecure. Okay, everybody knows that's insecure. So I need multi-factor authentication. Then I go to a web browser and I download my mail, and in my mail is a bad URL or a GIF or a JPEG or a document that has a virus, Trojan horse, worm, and a keylogger. And now I go sign in the mainframe of my user ID and password. And I just gave my user ID and password to the mainframe where the critical jewels are to the bad guy trolling the keylogger. And so he doesn't give a crap about your multi-factor authentication on your desktop. He wanted that mainframe password. Okay, so it's so easy to bypass security with that kind of environment, unless you're on SNA or something like that. So the idea is that the consistency, it's a recurring theme for me, is that whatever you're doing on one platform, you should be doing on another platform. It's not, unique to the mainframe. So if you're going to use MFA one place, you better be using it at every place, because the risk is the same regardless of which platform you're coming from or going to. And again, this chart says the same thing. If I adopt MFA for the desktop, duh, why didn't I do it for the mainframe? So, it's really simple to bypass this stuff. And if you'd like, I'll show you how. And again, one of the funny things, again, a quick story, Fort Knox. I think it'd be the most secure place in the world, in the United States. It's the home of all the gold. And when you look at the gold, it's got all that, barbed wire, concertina wire, razor wire around it. All right, but I'm on the Army base, and that Army base it's the HR, the Human Resource Department for the Department of Defense. So they've got all the personnel records in there. And I walk into the building, and again, any building I've been into once, you look at it, and there's the entry door. Over there, where the camera is the secretary of the woman, and there's the data center door right there. You go in and sign in, and you go into the building, okay, and you go visit whoever you do. I said, "Do you want me to break in?" And they go, "Nah, you can't get in here." "Oh, watch this." So I go over. As I leave the building, I said, "I'm going to go sign out." "You don't need to sign out." "I'm going to sign out." "Hi, I just want to sign out." "You don't need to sign out." "Oh, really? What's your name?" "Veronica." "Veronica, nice to meet you. You're so pleasant." "That's great." Walk out the door. I said, "Just give me 2 minutes." So we wait outside. I wait for a corporal or a private, somebody that doesn't have a lot of guts. Sergeants and above have guts. So I wait, I follow a private in. "Hey, Veronica, how's it going?" And the guy holds the door open for me, and we walk in. So it's all good, but that's as simple. So once you're in, now what can you have access to? Just social engineering has as much, the physical security. You can do all kinds of stuff once you get into someplace. Again, why do I care about any of this? What's at stake? It's about your brand reputation. As I mentioned earlier, it's a black hole. Once you detect a problem, how much are you going to spend to go fight it and resolve it, okay? So, again, one of those myths. 80% of the world's mission critical data is sitting on a mainframe. Is it true? I don't know. I think I made that up 10 years ago. I don't know, when I was at IBM. But the reality is, even if it was true, they made a copy of the data. So therefore, it's half the data in the world, okay? Because they made a copy in a data warehouse and a backup archive, okay? There's a lot of data on a mainframe, but whether it's 80%, it's important, okay? But there's copies everywhere, okay? Customers are looking for integrity, all right? And by the way, we can do all the security in the world. That doesn't matter, because The internet is the wild, wild west, okay? And whatever we do today to protect something, tomorrow the bad guys will figure it out. And by the way, when they figure it out on a mainframe, like they did at TJX, they don't tell anybody. Why? It's the goose that laid the golden egg. If I'm in to win and to take money, okay? So in TJX's case, it was 3 years that they were getting it. And the only way they got caught was the bad guys bought $8 million worth of gift cards at Sam's Club and Walmart. And it was Sam's Club and Walmart that realized we're not getting paid. We're not getting our money. And so and they did the common denominator, boom, it was TJ Maxx or TJX companies. So I remember telling my mom this and she goes, oh, I've never used my credit card there. And she calls me up 5 minutes later, the bookmark on her book was a credit card from them. I'm like, yeah, get rid of that one. But you look at operational risk now, and the other thing that's important is it's real time. You've got, real time means prevention, not detection. So what are you doing for anti-fraud measures, anti-money laundering? It's when you find that stuff out, it's a little bit late because again, now you're in diagnostics mode, you're in correction mode. You haven't caught the guy. What can you do to prevent this stuff from happening in the first place? And then the spreadsheets for what's it going to cost you, you have no clue. Because brand reputation is the worst factor. Okay, if somebody says we don't like your company anymore, they have lots of choices. Okay, they're going to go elsewhere and figure this stuff out. So, that's where you really got to protect yourself. I look at stuff like this. This is one of those charts. I think it was used for WebSphere or something like that. Like, can you imagine how complicated your environment is? The reality is, I look at flowcharts of data. Where did the data go? I don't care about the applications. Where did the data go? It started off here as a system of record. Then it got moved to data warehouses all nither and yonder. And the question is, do you have a consistent policy regardless of where that data resides for protection? I know the answer is no, okay? Partly because the tools are not the same. The tools on a mainframe are different than the tools on Windows, are different than the tools on Linux. And so by default, if you don't have the same tools, there'll be something changed. And as I mentioned, those windows, wherever there's changes in how you operate stuff, that's what the bad guys are looking for. That's what they want to seek and find, those kind of windows. And especially the internal bad guys, because they can figure that out a lot easier than somebody just hacking in from the street. Mark Wilson will tell you about, the kid that learned about the mainframe, got his little TCP/IP connection, figured out port 23 was telnet, tried to figure out passwords, Google them, and get in. But he's still, there's still some insider knowledge on data representation, stuff like that, to get to some things. And it's a lot easier when you're on the inside to get this. Like I mentioned before, the operational model is totally different. If you're in a detection mode, and again, we're talking about databases, but who's in charge? Oh my God, I'm drooling. I'm jealous. But that, you didn't get on camera, don't worry. But anyways, you look at this stuff and say, how did I get in here? How did I get access to this data? And can you protect it the same way? When you detect these problems, you're going to spend a lot of money. So if you can prevent it, it's so much easier to do it. Now, again, it's not a panacea. You can't assume, because the bad guys are always looking for ways around your prevention modes. But the more you can spend in real-time prevention, there's a fixed cost associated with that. With detection, there's a fixed cost with the acquisition of the products, but then you're going to spend God knows how much money in trying to resolve it, and then the whole wild card of brand reputation. All data belongs on a mainframe. Again, not reality. It can't be reality. There's never going to be a single copy of data. Yes, you can say there's a single IMS database, there's a single DB2 database as your system of record, but you have backup copies, you have archive copies, okay? I remember, you get into just archive. What's the protection of your archive? Is it a tape library? Do you send the tapes out? Do you put does your company put a lock on the back of the truck? Okay, did the truck roll over and spill the tapes out? Yes, those are known problems. Where they put the lock on and they're going to drive that truck 100 miles to a different data center. The truck rolled over, broke open, and tapes rolled out. Did you get them all back? I don't know. We didn't keep an inventory because we figured it was locked. Boy. Again, the fewer copies, if you flowchart your data, the fewer copies that you have, the better. And again, this goes back to how do you access data? I'll talk another time about shadow IT, but a lot of data is copied, and you have your new programs working off the copies. But each copy needs the same rules in order to be compliant. So you can go and say, oh, I've got to meet personally identifiable information against IMS. We did it. But where's the copy of the data? Do you have the same rules there? Oh, no, we're talking about production. No. The bad guys are looking for any copy, not just the production copy of it. And then test and application data, and I'll give you some good examples of that later on. But again, consistency, if I drive that home. End-to-end views, wherever that data exists, you need to do the same thing regardless of where it sits. So we have the system of record. We have the system of insight, if you'd like. The system of engagement is wherever the end user interface is. All these places are data access portals, if you think about it in those terms, okay? So do we have the same access control policies, same authentication policies, same compliance, reporting, and stuff like that? Logs, who did this? What are the anomalies of this kind of stuff? Again, I'm just thinking out loud here, but I'll go back to the TJ Maxx example. They got hacked locally, but then it was Hungarians that had the data. No offense to any particular person that's Hungarian here, but they had the data. Now, imagine this. Did you, and these are the questions I asked, do you audit failed logons? Yes. Do you audit successful ones? No. If a store manager looked at the inventory of the store, how many times a day do you think they did it? 25. If you did it 400 times, would you notice that as an anomaly? No. If their IP address was from Hungary instead of Whittlebury, would you notice that? No. Hello, I think you have a problem. And in that case, by the way, in their environment, they were not encrypting the user ID and password when they signed into the mainframe. So if we know all LAN traffic was stolen, so were the mainframe user IDs and password, but they had no audit records to prove that. I don't know, maybe they took it, maybe they didn't. This one, it was interesting. This chart, I resurfaced. It was actually for a store, it was for a retail store brand that wanted to do better data warehousing. And they wanted to see how end caps were being sold. They were at, let's say at Walmart and it's Nestle, and they had a whole bunch of stuff at the end cap. They wanted to see how the inventory was doing. But doing decision support on the mainframe is too damn expensive. So let's move the data off to a data warehouse someplace else and we'll do the analysis there. Now what's interesting was, because of the MIPS being consumed to move the data here to there, they can only do it once a month, okay? So their analytics, I kind of asked them about the analytics, do you have real time? Wouldn't real time, well, that'd be better, but it's so expensive. So that's the old mainframe, the mainframe of the 90s, early 2000s. But that's where this chart came from. But now let's think about it with personally identifiable information. So if we're gonna go protect it and do compliance, we pick these. Sorry, I'm not allowed to move, I forgot. We're gonna pick the main database here, the system of record here, and the system of insight. Those are the audit points of control, and that's what all your master copies would say. But what about all the temporary data? How did you get it there? Extract, transform, load, FTP, all that stuff. So do you have audit policies for all those copies of the data? Nope, most people don't. Okay, and so that's where you start saying, can I get there? Can I find that kind of information? And so then what's the answer? What do I do? Well, let's reduce copies and increase the resiliency of the environment. Let's move everything to the mainframe. Okay, well, we'll get rid of, first we'll go, instead of FTP, we'll use a shared file system. or data virtualization for that matter, so that we have the same copy of the data. That's a good thing. That's a start. We eliminate at least one temporary data set. Another one is, let's just move everything back to the mainframe, do it all there. That's nice, but it's unrealistic in a lot of cases. So again, shared virtualization, data virtualization, we can share or have that as a real-time access. So it's a decision support application, but the database is back at the mainframe. And the net effect is we've reduced the number of data copies. So there's opportunities here just on, as you look at your data flows, to reduce those data copies and then reduce the number of audit points of control. And again, make this more of a vault type mentality. Same kind of thing here. It's really the same flow, but when you look at the cost of ownership of this kind of thing, and over here, this could be things like IDAA, going after shared data. A lot of that data is flash copied, but it's inside the mainframe, so it's really not accessible to anybody on the outside. But you're totally changing the game in terms of operational costs and complexity. Did the tape end? Can I stop talking? No. So again, how you look at it, the cost of ownership of the different deployment models is dramatically different based on the way you choose to deploy. But the problem of compliance and managing data access controls are the same regardless of which deployment model you have. So all these things factor into your overall cost and security. Getting into data virtualization for a second, sharing data can actually improve insight. As I mentioned before, in that store application, they had a month's worth of data. They can only look at it once a month to look at trends. Well, sometimes, there's weekly, there's daily trends that might be important. In one store, there was a run on a particular product. Okay, why? And well, there was a hurricane or a tornado, so they bought a lot of milk and water and bread and stuff. Okay, then that's an anomaly. We don't have to worry about that. But you can also react to that too, because some of these places are what I call, continuous flow manufacturing. If the shelves are getting depleted, well, then I want to ship more to that store to keep up with the demand. Let's sell more stuff. Quick aside on security, I'm sitting, my sister is a broker. Never mind, this is being recorded. So I'm not going to tell you about my insider trading scandal. But needless to say, the IBM stock rose 12 points that day, which was pretty phenomenal. But it's all about continuous flow manufacturing. Anyways, the shared data can have some tremendous insight to you too. So it has some value being able to do that, but and in doing so reduces some of the security ramifications because it's one less image for the business to go manage. It also gives you, the performance of that type of shared model can run phenomenally better than if you're trying to extract, transform, load, delay, and then look at the data later on. Different people have different roles, different sets of questions. Are they a security practitioner, the info security person? Are they a compliance officer? Are they just in the IT area, systems programmer, database administrator, or somebody in the line of business? Okay, and the questions they ask, again, these questions are typical for any platform, any data source. Okay, it's not just about the mainframe, but data at rest, data in flight, data, removable media, tape, CD, worm devices, the cloud, different access points. Going over here, what are the different monitoring tools that we have? What's real time? What's detective? And then do I have normal access controls and this stuff? DevOps. DevOps is a huge new field. You're hearing a lot about that here. But as a database administrator, what do they have access to? Is it production data? I hope it's test data, as an example. So, that kind of stuff is really critical to look at those things and what are the access control policies that you have around that. If you're looking at just the whole role of data, you start with discovery, classification of the data, how vulnerable is it? And again, the question has to remain on every place the data is located, not just the system of record or the system of insight. How do they get access to it? What's the login process? What are the access control policies? Who's touched it, who's seen it, who's read it, who's updated it. Who do I have to block from seeing this stuff? How do I protect it, compartmentalize it? And then how do I mask it and encrypt it? Data masking, everybody know what data masking is? Okay, that's kind of important. I'll show you a hack later on where, you give production data to the test people. Yeah, that's really brilliant. Again, who are they? So all these things, all these tasks here, there's products to do this kind of auditing control. IBM offers the Guardian STAP capabilities across a variety of databases. Again, same type of rules. How do you apply this knowledge, these tools, these skills to data wherever it exists? DB2, that kind of stuff, the IMS, vSAM, database, SQL Server, Oracle, Mongo, NoSQL, CloudDB, doesn't matter. Okay, the problem's the same, but the tooling is different based on the platform and stuff. And again, it's a life cycle. This data moves like that flowchart I showed you earlier. Data moves everywhere, and if you're really in the compliance business or something, you've got to look at it as much on the mainframe as on the other platforms. And when it does go to the other platforms, don't abdicate, because again, I've been at shops that, wasn't us, I'm a mainframe guy, thank God it wasn't us. And then you proceed to explain, ask them questions, and they're like, oh crap, we're just as bad as the distributed guys. You've seen this chart before, probably. Again, the whole life cycle of encryption. And the point of this chart, again, is to distinguish between what's done at the physical layer, the full disk tape network type layer, what's done at the data set layer, vSAM and stuff like that, what's done at the database layer, what's done at the application layer. Database area, things that you have to worry about are things like buffers, okay, and what's in memory. Anyone ever hear of multi-level security? Okay, so I helped architect that. You can actually look up lockheedmartin.com, in their news file, look up IBM and NGA, the National Geospatial Agency. But what happened prior to Gulf War I was the National Reconnaissance Office would take spy satellite pictures. You ever see Patriot games, Tom Clancy? They send the spy satellite out over the desert, and they change the angle, and they get the bad guys and stuff. That's true. Oops, on tape again. Patriot games, Will Smith, Gene Hackman, that's false. So anyways, National Reconnaissance Office takes these megapixel pictures. The National Geospatial Agency builds maps around it, and the National Security Agency analyzes it and does stuff, sets up stuff. So those megapixel databases are petabytes, and what they were doing was sending them agency to agency. You're in a war zone, it takes a while to get that information from one place to another one. So sharing data is kind of critical, but it's on a need-to-know basis. And so multi-level security provides that type of data access on a need-to-know basis. I actually wrote a book on this, but if you think about what I call it the Citigroup example, Sandy Weil was the chairman of Citigroup, and he was accused of insider trading. So what they said was the insurance division and the stock division were not allowed to know what was available in their client's banking information unless the customer opted in to share that stuff. Because otherwise, we're all Citigroup employees. And again, I'm not disparaging them because none of this ever happened. I'm just giving you this as a theoretical thing. But you could, I could, as a salesman for the insurance business, if I knew this guy had a lot of money, well, I'm going to try and sell him more and more insurance, okay? And unless you opt in, like GDPR, you don't have a need to know that kind of stuff. Well, same thing in these kind of military applications. So we built this all into ZOS. So just got to laugh. I retired 6 years ago. IBM just announced this, trusted protect options or something, these new things on the Z15 where you can send, keep the token or whatever, the security access control. Did you guys think about MLS, which is still in the base operating system? No? I said, yeah, it probably would have been a little bit easier to implement, but regardless, there's some really cool technology for security, privacy management in there, but you have to, knowing the buffers, when you take a standalone dump, You don't want that information dumped so that anybody diagnostically can look at this stuff. Send a dump into IBM. Oh, look at that. No, I'm not saying they do that. I got asked by an insurance company. They found out that all their customer data was on the internet, being sold in the dark web. So they brought me in knowing I'd done other forensic work. I'm a member of the Secret Service Crime Task Force. And they said, could you write some programs to figure this out? And I said, well, you have Guardium STAP. That'll give you audit records. And I said, let's look at that stuff first. Nothing. And I said, well, can you write GTF and SMF records? Look at those and just write a program to analyze them because we want to find out who that bad guy is and string them up. I said, all right, let's say I do all that work and write that program. Let me ask you a couple leading questions first because now I'm the defense attorney of the guy we just caught, all right? Did you ever make a copy of the data and test? Yep. Any audit records there? Nope. It's test. Did you mask the data in any way? Nope. It's all production data. Okay. Did you ever give the same data to the development team? Yep. Mask it? Nope. Audit records? Nope. No RACF. It's for development. Do you offshore any of your development to a third world country? Yep. Okay. Ever made a copy for a data warehouse? Yep. Any audit records there? No, it's read only. Okay. Ever make a copy and give it to a salesman, put in a CD in his laptop so when he's going around, selling stuff, he has all that information? Yep. Do you have any audit records there? Nope. Read only. Thank you. That's called Swiss cheese. Okay. So I said, you guys are out of control. So let's lock it down. Let's figure out a way to make this more secure. So what do? Let's put Guardium, STAP, and RACF everywhere. Oh my God. No, you don't want to do that. So let me give you some alternatives. First thing is you can clone and mask data. I list the IBM cloning tool or the Optum test data masking, but do something, fake the data. The other one that I thought was hilarious was, so you got a gigabyte, a terabyte, I don't care how much data it is, because in some of these test shops, you want to have the same scale as production. And so over time, production database gets updated. So they wanted to update the data on the test side. And so they wanted to remask everything. I go, why? Oh, because our production changed. So we have to keep it in sync with this. It's fake data. Who cares? Okay, I just need a scalable version of it. So once you mask data, a lot of times it's a one-time deal. Now, if you add new schemas and update the database, yes, you have to update the test data appropriately. But you don't have to continuously, somebody correct me if I'm wrong, but you don't have to constantly do data masking daily to do this kind of stuff. But development should not have any real production data. They can have some amount, like order part numbers. I don't care about that. Okay, that's cool. It's no personally identifiable information. It's on your catalog anyways. That SKUs, that kind of stuff. But maybe pricing you don't want to put out there. By the way, I mentioned that only because there was a shared database case, and it was one of our multi-level security accesses where, again, a big retail store gave all their partners access to the inventory to bring stuff in. Well, what they found out was this guy could see this guy's price. And so two things could happen. One, the good thing is I'm going to sell it to him at a lower price in order to win the bids. And that's a good thing, I guess, kind of except for this guy over here. And then the bad thing is, hey, you and me, let's charge more and screw this guy over. So, you even got to think about pricing, when you share this stuff with partners. That's a database sharing thing. So how do you protect that? And in this case, multi-level security would say people at the business, the retail store, could see all the data, but these guys could only see their rows. They couldn't see anybody else's stuff. So it's another way to protect data. Data sharing. These data warehouses, you can have real-time access to the data now. You don't have to FTP this stuff. So it's a business intelligence application. Everybody's on the network. So share the data real time instead of making copies of it. And boom, now you're using the mainframe audit will apply to these remote accesses as well. Same with a mobile salesperson. They have mobile access, cellular access to this stuff. They don't have to worry about downloading it, in most cases. and they have real-time access, so any access they make is audited. Multi-factor authentication, you do it on your desktops, do it to all these environments as well, and just protect access to the data. And then encrypt the production data, okay, with whatever you need to do that, again, so somebody's not making a copy of it. Again, net effect is, and I mentioned this as mainframe stuff. This could be Microsoft Windows and Oracle and all that kind of stuff. Same type of workflow here. Fewer points of audit control. You're going to improve security and you lower your operations cost. Anyone ever hear the scrub utility for IMS? Okay, anyone have IMS and not hear of it? Okay, so you do logs. You're doing diagnostic logs. IBM's Problem Investigator, Transaction Analysis Workbench will all create logs. Well, logs have personally identifiable information in them too, because they're a record of the transaction that occurred. The scrub utility, there's two versions of it. One is a batch type of facility that'll go in and clean out, you tell it what are the personally identifiable fields. It'll clean out those fields so that you can give that to a third party, IBM, other vendor and stuff, to do a diagnostic information on there. And it's a free utility. It's in the IMS tools base, which is free, but it's also part of the performance analysis toolkit. Then there's another version of it that there's an exit, but that exit, some people could bypass it. I think if you go straight to the log, you might see that, through ISPF, you might see the data. But as a viewer, it does have some capabilities to give you extracts and build files that you can now remotely distribute without giving away your personally identifiable information. So again, one of those things, part of the thing that IBM's talking about with the Z15 is an ability to redact information. That's what scrubbing is. It's redaction of information from a log record to hide that sensitive information, but they're focused on this kind of stuff. So I kind of see over time this kind of scrub utility and the redaction tools announced with the Z15 kind of coming together. I'm making that up, but it just logically seems you want to have a consistent way of doing data redaction regardless of where data exists. Okay. This chart is only interesting because you'll see in another presentations that I do about this Rubik's Cube of different roles. This is data visualization using the query management facility. But one of the things in a DevOps environment is there's YAML files. Everyone ever hear them? Okay. The YAML file kind of describes the files and stuff that you use in a development way. And one of the things you can look at, and you can't see it very well on this chart, but you can look at it, but this has all the access control right there. This has all the access control, what users have access to databases, the development databases. So even using tools for visualization can be used for things like security and audit control if you wanted to. So there's information out there. This was kind of a homegrown thing that some of our developers did, but it's kind of important too, because those, you can call it the code artifacts if you want. What's the protection against them? That's data being done. So in summary, there's a lot of different steps you can take. I mean, typically we think about the 4As, authentication, access control, audit, and then data encryption and stuff. But there's so much more that can be done now: anonymization, redaction, hardening of data through encryption and stuff, and thinking about prevention versus detection. So just wanted to share some of these things, and I'll give some more tomorrow in the enterprise security myths, getting into some of the desktop problems you got to be cognizant about in this area, and some other lovely myths behind the mainframe. Any questions at all? Anything I missed? You actually helped me. If you think of areas that I didn't talk about that you think are relevant in a database area, I'd certainly be interested in that too, because I'm not pretending I'm the world's expert on this stuff. Yeah.
Yeah, thinking about your scenario of passwords being sniffed from Windows. This might be a separate presentation actually, but how would that compare to using something like Firewalls on Windows and then trusting the...
I could do a whole different, so let's go back into multi-factor authentication. So it's about something which would be a user ID and password, something you have, which might be a token, your cell phone, and something you are, biometrics, some combination of those things. Kerberos giving you a third party if you'd like, but how did you log into Kerberos? Now is it via certificate? That could be something that you have. So that'll be better than a user ID and password using that type of, and when you think about Kerberos and private and public key, that's kind of a third party, a handshake there. Those are improvements upon just simple user ID and passwords. And by the way, the state of the art in the mainframe is 8-character user ID, 8-character passwords. We've had passphrases for 17 years now, and they're still not exploited in every product. And if you look at homegrown KICS applications, IMS applications that drive a sign-in, most of them are still 8 characters. So we have out-of-band capabilities to handle that. But there is a separate presentation on multi-factor authentication that can talk to more details behind that. Sure, go ahead.
The scrub utility, I've not heard
The scrub utility, yep.
How do you compare that to something like encrypting the data and throwing the key away?
You do that too. If the data is encrypted, then who cares? Then that's as good as being redacted. If the key is not available to the person looking at the log, then that accomplishes the same task, right? But a lot of times that's application specific or environmental specific. You might say in by log, that's an encrypted field, so do it that way. But that requires program changes and stuff to facilitate that. But yeah, so now you're at the application level of security. What do you do at the application level to further protect things? But yeah, certainly that's an option. Yeah. But regardless of the means of doing it, encryption, redaction, one of the two is necessary if you're going to share that data with unauthorized people. Yep. All right. Well, thanks very much for your time. Really appreciate it.